Hi, welcome to the lesson on ratios and rates. So let's go over ratios first. A ratio is a comparison of two numbers and they're written as proper fractions or improper fractions. Now you'll also discover that there are three different ways that ratios can be written in. So let's go over some examples. So for example 1, it states on a field trip, the total number of chaperones are 20. 11 chaperones are females and 9 chaperones are males. So what we have to do here is highlight the important information. So we have a total of 20 chaperones, we have 11 females, and we have 9 of them that are males. And so what we're going to do here is answer every other statement. So we're going to look for A, C, and E. Okay, so starting with A, we have to find the ratio of female chaperones to male chaperones. So we're going to start with the word to. So that's one way it can be written in. So let's see, female chaperones, there's 11. So 11 to, and then there are 9 male chaperones. So 11 to 9. And then for C, we have to find the ratio of male chaperones to the total number of chaperones. And so this time we're going to use a colon. And so that will be expressed as the ratio of male chaperones, 9 to, and total number, 20. 9 to 20. And then for E, we have to find the ratio of the total number of chaperones to number of male chaperones. So this time we're going to use a fraction bar. So the total number is 20. So that's 22. And the number of male chaperones is 9. So 20 to 9. So now let's go over another example using ratios. Okay, so let's say you have a ratio of 10 to 15. Well, this can also be stated as 10 out of 15 or its equivalent. So we have to find the greatest common factor for both 10 and 15. Divide the numerator by 5, because 5 is the greatest common factor for both numbers. Divide by 5 in the denominator as well. That means the equivalent to 10 out of 15 is 2 out of 3. Because remember, 10 divided by 5 is 2, 15 divided by 5 is 3. Now, anytime a ratio is used to compare two measurements, we have to use the measurements in the same unit. So in other words, we must use like measures. Let's take, for example, 3 hours. Let me use a different color here. Let's take 3 hours to 190 minutes. Let's say that you have to express this in lowest terms or simplify this. As you can see here, we are converting from larger units, hours, to smaller units, which are minutes. And so we must multiply. But in order to convert 3 hours to minutes, we must ask ourselves, well, how many minutes are there in 1 hour? We know that there are 60 minutes in 1 hour, and because of this knowledge, we can apply it to 3 hours, meaning that we have to multiply 60 by 3, and that gives us 180. 180 minutes is equivalent to 3 hours. 180 minutes over 190 minutes. Simplifying even further, we can cross out the zeros. We're left with 18 minutes to 19 minutes, or 18 minutes out of 19 minutes. Now let's talk about rates. So then what is a rate? So a rate is simply a ratio of two unlike measures. And a rate is usually simplified to a unit rate and is expressed as a quantity of one. You may hear something like miles per hour, price per pound, etc. What we do though is set up proportions to find unit rates. And so proportions usually look like this. So let me wipe this out. So let's say, for example, you have 20 miles to 4 hours. And that's equal to 5 miles to 1 hour. Now this is a proportion. This is your unit rate. Notice that we have it expressed as a quantity of one. Let me just place unit rate here. And this is your ordinary rate right here. So knowing this information, let's solve a couple of word problems. So for the first word problem, it says it takes Jamie 5 minutes. 5 minutes to text 250 words. At that rate, how many words can he text per minute? So here we have unlike units or unlike measures. We have minutes to words. This is our given ratio, meaning that these have to be stacked on top of each other. So we have 5 minutes to 250 words, and I'll use W for words. We're setting up a proportion here. So it's saying at that rate, and remember, a rate is usually simplified to a unit rate. How many words can he text per minute? So what I'm going to do is place 1 minute in the numerator because we want like units to be next to each other. Unlike units should be stacked on top of each other. And so since we're looking for how many words he can text per minute, well, since we don't know that, we can express this as X. So we're solving for an unknown variable. We're using an unknown variable to solve for how many words. In this case, what we're going to do is cross multiply. So 5 times X is equal to 5X. Cross multiplying 250 times 1 is 250. Now we have to divide by 5 on both sides because we need to isolate X. And X is going to give us how many words he can text per minute. So X is equal to 250 divided by 5, which is 50. Meaning that Jamie can text 50 words per minute. Now let's take and work with example number 2. Why don't you pause the video and see what you come up with? So you drive 420 miles in 7 hours. At that rate, how many miles could you drive in 8 hours? So let's set up our given ratio. We have miles to 7 hours. 420 miles to 7 hours. At that rate, how many miles could you drive in 8 hours? So where is the miles going to go? In the numerator or in the denominator? So it belongs in the numerator because remember, like units are next to each other like we have up here. And unlike units are stacked on top of each other. So at that rate, how many miles? We don't know that, so we're going to place X there. And we have 8 hours. Notice this is at the bottom because we have hours in the bottom as well, or in the denominator. This time we can go ahead and cross multiply. We have 7X is equal to 420 times 8 is 3,360. Since we have to isolate X, we have to divide by 7 since we're multiplying 7 times X. The 7's cancel, and so X is equal to 480. So that means you can drive 480 miles in 8 hours. So that's all we have for this lesson. I hope it was helpful to you, and I look forward to working with you in the next lesson. Take care.